In this video, I'd like to talk about the math question of the day for January 28th, 2023. And for this problem, we need to find the derivative of the following function. This function f of x, which is the square root of 5x plus the tangent of 4x. Now, to solve this problem, we need to understand the basics of calculus and basically everything that comes before that, including trigonometry. So at this point, go ahead and pause the video, see if you can solve this on your own. And after giving this a reasonable attempt, spending at least a few minutes trying to solve this, then unpause the video and we can work through this together. Now, assuming that you have given this problem a try, we can go through this together. And as always, if you have any suggestions for a question of the day, feel free to leave that as a comment below. Now, when taking the derivative of some complicated function, we will likely need to use the chain rule or possibly even the quotient or product rules. But for this function, we're dealing with a square root. And with square roots, or really any roots, it's helpful to rewrite these as fractional exponents, and then we can just use the power rule for derivatives. So let's say we have some square root expression, just root x. We can rewrite this as x to the 1/2 power, where the root we're taking, in this case a second root, would be the denominator of the exponent, and the numerator of the exponent is just the exponent on the inner variable. So we have x to the 1/2, but if it was a cubed root, then this would be to the 1/3 power. And remember that when we have some function, let's say x to the a, and we take its derivative with respect to x, we use the power rule. We bring down the a, we multiply by x, and then we subtract that exponent by 1. So we can apply that to a square root function. If we took the derivative of the square root of x, or the derivative of x to the 1/2 power, we bring down the 1/2, and we subtract the exponent by 1. This will now be minus 1/2. And if we want, we can rewrite this using radical notation as 1/2, where the square root of x is in the denominator. But ultimately, taking the derivative of a square root is fairly straightforward when you rewrite it as a fractional exponent. So let's apply that here. We can just rewrite this as 5x plus the tangent of 4x, and all of this is raised to the 1/2 power. Now, we will also need to use the chain rule here, since we have a function within a function. We have composite functions. We have this 5x plus the tangent of 4x within the square root function, and then we also have more functions on the inside. Namely, we have this 4x on the inside of the tangent function. So we'll need to apply this chain rule repeatedly to be able to solve this. But remember with the chain rule that if I make a little bit of room, we can write it out formally. If we have, let's say, g of f of x, and we want to take the derivative of this composite function, we do the derivative of the outside, so g prime of f of x, we just rewrite the inner function, and then we multiply that by the derivative of the inner function. So this right here is what we call the chain rule. So applying that to our particular function here, if we work over here, can take the derivative of the outside function, which is that square root function. We write the 1/2 in front. We're just using the power rule. We rewrite the inner function without changing it, and we subtract the exponent by 1. So this would be minus 1/2, and now we multiply by the derivative of the inner function. And when you have a sum, you just take the derivative of each individually. The derivative of this would just be 5. We're using that power rule. The 1 comes down, 5 times 1 is 5, and we get x to the 0, and anything to the 0 power is equal to 1. So the derivative of this is 5, and the derivative of the tangent function is the secant squared, but we're using the chain rule since we have a function within a function. So we take the derivative of the outer function, that tangent function, where we just rewrite the inner function inside that. And then we take the derivative of the inner function, and the derivative of 4x is just 4. We're using that power rule like we did with 5x. So this will be multiplied by 4 here. And this right here would be our final answer. And of course, we can simplify this, but I do want to mention that if you forget the derivative of the trig functions, namely the trig functions that aren't sine and cosine, so tangent, cotangent, secant, or cosecant, what I would recommend doing is rewriting them in terms of sine and cosine. So the tangent is really just the sine over the cosine, and all of this relies on knowledge of what the derivatives of sine and cosine are. But assuming you know those, then the tangent is really just a quotient, and we can apply the quotient rule, that if we have two functions, f divided by g, and we take its derivative, we get the derivative of the numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator function, all divided by that denominator squared. So if you applied this quotient rule to the tangent function, you will find that you get 1 over the cosine squared, which of course is equal to the secant squared. So that's one way to rederive the derivatives of the trig functions for yourself. And like I mentioned, at this point we can simplify this. This is really a square root, and it's in the denominator since this is negative. So let me just rewrite everything here. We have all of this in our numerator. We have 5 plus the secant squared of 4x multiplied by 4. And that 4 is on the outside, so really we could put the 4 in front here. And then all of this is divided by this 2 multiplied by the square root of this. We have 5x plus the tangent of 4x.